Well, let's go ahead and finish up week 5. We'll cover chapters 15, 16, and 17. 16 is a very, very, very short chapter. 15 and 17 are almost self-explanatory, but they just kind of really want to emphasize some things as far as for chapter 15, it basically says combining strings and variables. And so they really want you to know the difference between the primitive data types and the object data types. So again, they go back to let me open up. 15.1. So they really wanted to stress the whole concatenation again, kind of review that. So here we've got let message. First of all, we've got a function. It's called sayGreeting. We're going to pass in a greeting, a who, and an emoji. So we're going to basically create a variable called message. We're going to make it equal to the greeting, and we're going to concatenate a comma and a space, and then we're going to concatenate the who, and then we're going to concatenate a pipe symbol and how are you space, and then we're going to concatenate an emoji. So down here I say let Batman equals sayGreeting, good morning, comma, Batman, comma, and then the emoji, it's a bat emoji. And again, I think they should give you emojipedia.org. You can go and get those. I just copy those directly into your code. And so I go ahead and write it and do a console as well, right to the console log. So if I go ahead and run that, it basically looks like that. Good morning, comma, Batman, pipe symbol, how are you? And then there's the bat little emoji. Okay, and if I basically open up the console, we'll see the same thing there as well. And there it is, and there's the bat. Okay, so that's that. There's also this thing called string interpolation, where it's concatenation, but it's different. And how that works is, let's go ahead and open it up and take a look at it. It's pretty much the same thing we just saw, except, so we got the function sayGreeting, greeting, who, and emoji, and we say let message equal. Now, very important, and there on page 176, they show you which button you need to press. It's just to the left of the number 1 key. I hope Macintosh is the same, but it's basically a dash that kind of goes at an angle. It's an apostrophe, but it kind of goes at an angle. You start with that, and that tells it we're going to use interpolation. And what we do is we have a $, and then it's surrounded with braces that says, okay, this is going to represent the greeting, whatever's brought in. Now the comma, it's only there for display purposes, because it's going to display this greeting, whatever's brought in, and then it's going to print the comma. Okay, so this is exactly how it's going to print. So the $ greeting, again, remember it's got the braces around it, and then the who, and then the how are you, see the pipe and how are you, and then the emoji is $. Again, those are braces. And then it ends with the same apostrophe, slanted apostrophe. What do they call that? Backtick character is what they call it in the book. And then we're going to say this time, let Panda sayGreeting, hello, 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 and then police officer, and then we're going to have the panda emoji. We're going to go ahead and write that, and then the panda. I also wanted to show the math.py. That is we'll talk about that in just a second. So let's go ahead and run that. And there we get hello, hello, comma, and that comma is just part of that little string of stuff. Police officer, how are you? And there's the panda emoji. And if I basically expand that, or open it, so there I have hello, 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 please, how are you? And there's a panda. Now notice there's 3.14159, and there's pi. I don't know why I put that in there, honestly. It's strange. I can't remember why I put that in there. But anyways, we're going to be getting heavy into the math, numeric, reserved. It's basically a reserved word where it has all of the methods and constants that go with math. And we're going to cover that pretty extensively in the next couple of chapters. Chapter 16, I don't really have any examples to talk about that, but they do stress the fact that we do have these objects. We've got an array object, a Boolean, a date, a function, a math. A math is a function, so it's an object. And then we have a number object. We have a regex, which is regular expressions. And then we have string. And one thing they did kind of point out is if we basically did this, if I do let primitive text equal Homer Simpson, that's primitive text. But if I do let name equal new string Batman, now that is a string object now, and all of the different methods that come with the string will basically go with that as well. So there's a primitive text and there's an object. Some of the things we've seen so far, we've utilized some of the different methods. We've got index of, last index of, two uppercase, two lowercase, push. Yeah, I forget some of the other ones. But anyways, those are all the methods that come with the string. There's literally a lot of different methods that are available to us. You can look those up on the internet. But yeah, those are and they're very useful. They basically are pre-written code that we just get to use right out of the box. So it's pretty nice. Well, I know why I put math pi. If you look on page 181, there's the picture of pi, and I think that's why I put that in there. Dot length is another one that's built in. Those are methods built in as well. So the whole point of chapter 16 is to let you know that when you use these objects, you get a lot more useful code that comes in behind the scenes that we get to utilize. We're going to see what some of those are here in chapter 17. Chapter 17 is basically numbers. The whole chapter is all about numbers. So let's go ahead and open up. I just have one program to open. And I pretty much got everything that they talk about in here. So, oh, I didn't mean to run it. I meant to open it. So here we are. We got, so one of the first things they talk about is I can just say let a variable name equal. So here we got let stooges equal 3. And that's it. That's as easy as numbers get. If you've done any type of programming, like say in Java or Python or some other language, we normally have to declare what type of numeric values are going to be. Is it going to be an integer? Is it going to be a long? Is it going to be a float? Is it going to be a double? Okay, so we have all these different numeric values. That's the great thing about Java is we don't have to do that. You just make a variable equal to a numeric value. And if you look over on page 187, it says all numbers are converted into a 64-bit floating point numeric value. So we just throw a number out there, and JavaScript takes care of the rest. Now, if we did something like let some numeric value equal to double quote 14 double quote, that is not a numeric value, that is a string. So just know that. If you have something inside of double quotes, that is a numeric value. Okay, so they talk about the basic operators. So we've got addition, where it's a plus sign. We've got division, which is a /. We have multiplication, which is an asterisk. We have subtraction, which is a dash. We have what's called modulator, which is a modulus, I should say, which is a % sign. And what that does is that, for example, here I've got total, which is got 4 plus 26, which is 30. So it takes 30 and divides by 7. The remainder is what goes into this variable remainder. Okay, and the remainder is 0.28571. We can also do calculations like 1 plus average times 10, which in this case would be 60, because the average is total divided by 2, which is 15. We add that, which is 16. We multiply it times 10, which is 160. One thing I do want to point out, here I've got double pi is equal to 2 times 3.14159. We could also do this as let double pi equal 2 times math.pi. Okay, and we'll get more into the math stuff later on, but that's probably a little more accurate. Realize at the bottom of page 187, JavaScript does follow the order of operations. That means it does everything in parentheses first, then it does any exponents, then it does any multiplication or division, whichever comes first, then it goes back and does any addition or subtraction, whichever comes first. Okay, the next thing we have is incrementing and decrementing. And so here we have let I equals 10. I'm going to say let A equal I plus plus. That is an increment. It will basically increase it by 1. Okay. We can say let B equals I minus minus. That is a decrement. It's going to basically subtract 1 from I and put that into B. Okay. Then we have let C equal total, and that's going to basically take whatever's in I, which is 10, it's going to add it to total and put it into C. Then we've got multiplication, where I say total, which is asterisk equal I. That means it's going to take 10, multiply it times total, and put it into D. I can do division, which is total / equal I. That means it's going to take total divided by 10 and put it into E. Then we have F equals total asterisk equal I. That is basically exponents. It's going to raise total to the 10th power and put that into F. Now I put in a comment below that. We could have done that with the math object, which is math.pow, and then total comma I. That means it's going to raise total to the I power and put it into F. I don't want to spend a whole lot of time on octal and hexadecimal, but we can convert to octal. Octal is a base 8 numeric value that's 0 through 7, and there's nothing beyond that. We also have hexadecimal, which is 0 through 9, and then A, B, C, D, E, F. So there's a base 16 numbering system. So we can utilize those. To do that, we do 0, for octal, all those numbers. So anything that has 0 is going to be an octal number. And then everything hexadecimal is 0x. Anything that starts with a 0x is going to be considered a hexadecimal number. NaN, you're going to see NaN a lot in JavaScript, and that means not a number. That means you tried to do something and it comes back and says, sorry, that's not a number. I was expecting a number, and that's not a number. So if I took 1920 divided by the textual BLAH, blah, I'm going to get back an NAN, and we'll see that when we basically see that when it's ran on the console. And then, like if I said, let calculation equal double quote 14 plus 4, well, I'm expecting 18, but I'm going to get an NAN back. Let new calculation equal number. Okay, now here's how we fix it. This is how we fix that. If I use the number object and I put a string, a string that can be converted to a numeric value. In this case, a double quote 14 can be converted to a number. Number will see that and go, I'm going to convert that into a 14. We're going to add 4 to it and put that into new calculation. So number is also an object that we can utilize to, in this case, convert a string into a number. Random numbers. This is pretty cool. So random, we're going to use the math. And again, that is on page, we got the math object. On page 192 shows a few of the math methods that come with the math object. So we got the Euler's constant, a logarithm, a couple different logarithms. We got pi, we got square root. So we got some really heavy duty equations that we can utilize with the math object with all the different methods that come with it. We can use random numbers. I can say let random1 equal math.random times 100. We can let high equals, we're going to create a variable called high equal to 100 and low equal to 0. And then we're going to do math floor. Now let's talk about math floor first. Math floor says if I get a calculation and it comes out, let's say 3.2, the floor says go ahead and go to the bottom, and we're going to basically round that to a 3. I also have what's called a CEIL, which is also considered the ceiling. If I get 3.2, it says, hey, go to the top and go ahead and round that to a 4. So if it's in between, so for a floor, if it's in between a 3 and a 4, it's going to return a 3. For ceiling, if it comes back as 3 between a 3 and a 4, it's going to bring back a 4. Round, on the other hand, is going to round it just like we've learned in school. If it's a 2 for 3.2, it's going to round to a 3. 3.3 is a 3. A 3.4 is a 3. Anything 3.5 and above is going to be a 4. So that's how rounding works there. So here I got math floor. That means when I get my random number, because we want a whole number returned. So think of floor and ceiling always returning a whole number. So in this case, if it's basically between a 3 and a 4, it's going to come back as a 3. So here I've got 0 and 100. So I've got math random times 1 plus high minus low. So 1 plus high is 101. We subtract low, which is 0, and then we add 0 to it. So we're going to return. So what this is really going to do, this random number, this equation right here is going to bring back a random number between 0 and 100. So to simplify that, we can actually say, in this case, we want a random number between 0 and 10. We say let foo equals math times, or math floor. Again, we want a whole number, but bring it back the lower one. math.random times 11. That's going to bring back a number between 0 and 10, put that in the foo, and then we're going to display that on the console. Then if I want a random number between 0 and 100, I do a math.for, math.random times 101. I'm going to go ahead and display that in the console. If I want a number between 5 and 25, and it's inclusive, I mean it's going to include 5 and 25 in there. So to do that, I'm going to say math floor, and inside of that I want math.random times 11, and then I'm going to add 5 to it. I'm going to display that. It's going to be between 5. So again, I add 5, and it's going to basically to that random number. That's going to increase it between 5. It's going to start at 5, or it's going to be the lowest number can be 5, the highest can be 25. Here now, if I wanted to do all of these different random numbers, I could go ahead and utilize this function to do that. Okay, I've got low and high. I'm going to let r equals math floor random times high minus low plus 1, and I'm also going to add low to that. Then I return r, and that will basically get me anything I wanted to do up here. If I wanted to do 0 to 10, I would put 0 and 10. If I wanted 0 to 100, I would put 0 and 100. If I wanted to do 5 and 25, I would do 5 and 25, and it's going to bring that back. And I'm going to test that by doing just that. I'm going to say console get random number 0 and 10, 0 and 100, and 5 and 25. And we should get that back and be just fine. So let's go ahead and run this. Oh, sorry, yeah. Go ahead and run it. I'm going to do F12 to see my console. And so, my very first console is the nope up here. You notice I get NaN, not a number. My next console is the foo. So I get, basically I want to see a random number between 1, 0, and 10, and I get a 3. My next one is a random number between 0 and 100, and I get 3. I want to see it between 5 and 25, and I get 10. And here's my functions then. My last 3 are a random number between 0 and 10. There's 9. 0 and 100, I get 77. And 5 and 25, and I get 22. And if I keep rerunning this, I keep seeing a whole bunch of different numbers popping up there. Just random numbers with those parameters. I want it between those 2 parameters. Okay. So that's pretty much it for that chapter. If you look on page 195, we do have some trigonometric functions. We have cosine and sin and tan and all kinds of different a sines and arctan and then down at the bottom we have some square roots. We've got power. I can raise it like you saw the example. We can see it raised to a power right here. If I wanted to see it raised to a power, I could do that right there. We have square exponents, or no, it's called Euler's. Raise it to Euler's constant to a specified number, which is exp. We also have sqrt square root. We can get absolute values. I talked about all the random numbers. Okay, again, that's the end of week 5. If you have any questions, again, feel free to contact me. I'd be happy to basically take any of your questions or comments. If you're having any issues, again, experiment. I can't stress that enough. Play around with things. Try different things. If you have any problems, give me a call. We'll try to work it out. Okay? We'll see you next week.